Today we're continuing with scaled copies, and we are going to talk about a new aspect with scaled copies, which is area. So we're going to look at what happens to the area of a figure when it is scaled, when it goes through a scale factor and becomes a scaled copy. What is happening to the area of that figure? In your packet, go ahead and turn to this page of the lesson, to the first example here that we're going to do together. And we're going to do 1 and 2 together, and 3 and 4 I'd like you to try on your own after I've demonstrated it. So the first question we're asked for these two triangles is, are the triangles similar? Now, looking at them, it does look like certainly this is a bigger scaled copy than this, and it does look like a similar figure. The angles that are corresponding seem to be the same, or close anyways. And what we're going to look at now is, since they are similar figures, we're going to see if they're scaled copies. Do they have the same scale factor for all corresponding sides? So let's look first at filling in, being that this is the original figure and this is the copy. I'm going to fill in the base of the figure and then the height of the figure, which is perpendicular to the base there. So the base of the original is going to be 8. The base of the copy is 16. The height of the original is 6, and the height of the copy is 12. Now, these are corresponding sides, so are the two heights, because we're comparing corresponding sides on these two figures. So I do know that my scaled copy is larger than my original, which means my scale factor has to be greater than 1. Now, if I set up my ratio backwards and write 8 to 16, I'm going to get a ratio that simplifies down to 1 to 2, or 1/2. All right, that scale factor would not make a larger scaled copy, it would make it smaller. So I'm going to back up here because I did something wrong, and I'm going to write it as the side of the copy, 16, over the base of the original, 8, which then simplifies down because I can divide both of these numbers by 8 to get this. That means my scale factor is 2. So I can multiply by 2 to turn my original base into my scaled copy base. Then I'm going to check and see if that same scale factor works with the height. And it does. 6 times 2 is 12. So that would confirm that we have a scale factor of 2. Now let's look at perimeter. Perimeter is the distance around the outside of a figure. So it would be like walking along a sidewalk around each outside edge of this triangular park, or building a fence around the outside edges of a triangular yard. We're going to take each of these side lengths and combine them into one linear, one line, and take that length for our perimeter. So I'm going to add 6 to 8 to 10 and get a perimeter for that original of 24. I'm going to do the same with the copy and add 12 to 16 and to 20 and get a perimeter of 48. All right, then we're going to look for area. So with area, what we're going to do, and if you've forgotten, to find the area of a triangle, we take the base times the height. And really, we don't want to just do that. We want to find half of that. And let me explain why. If I take the base times the height of our original triangle here, that's going to give me the area for a rectangle that's 6 by 8. It has a length and width of 6 and 8. All right, but I don't want that much area. That's too much. And a triangle neatly cuts that rectangle in half perfectly. So I'm going to eliminate this half of the area I just calculated that I don't need. That's why I'm taking half of the base and the height. Or I could take the base and the height and divide by 2. So let's do that for the first one. For the original figure, 8 times 6 is 48. I want half of that. So the area is going to be 24 square units. I'm going to do the same thing for the copy, except I'm going to multiply 16 by 12 and then take half of that amount, which will give me 96. All right. The next two questions are really, really important because that is bringing together the idea of today's lesson. Let's first look at the perimeters. So we had the perimeter of the original figure and the perimeter of the scaled copy. The first was 24, the second was 48. Let's look at how those two numbers compare to each other. Do they follow our scale factor rule of times 2? Yes, they do. So the perimeter, we can tell, continues with that idea of having a scale factor of 2. Everything in the original is multiplied by 2 to get the scaled copy here. Let's check the area. We started with an area of 24, and then our copy had an area of 96. That's not 2 times bigger than the original like everything else here was. It's actually 4 times bigger than what the original area is. All right, that's interesting. So the area doesn't follow the same scale factor patterns that all the sides and the perimeter do. Let's look at the next example before we talk any more about that. So now we have 2 squares, and we have a smaller square, which is going to be our original. That's 2 by 2. We have our scaled copy, which is 10 by 10. Now the first question again asks, are the squares similar? Yes, they are. They're both squares. They have side lengths that are all the same. And of course, the angles are going to be the same, those right angles. So let's go ahead and fill in our table. The base of our original is 2. The base of our copy is 10. And the height is going to be the same because all sides of a square have to be the same measurement. So this should be easy to find the scale factor. So I'm looking for what will turn a side of 2 into a side of 10. I could set up another ratio where I take that measurement of the copy over the original and simplify that down. Or hopefully just by looking at this, I can see that if I take 2 times 5, I'll get 10. And the same rule applies to the height. All right, so my scale factor is 5. Now let's check that with perimeter. So on the last figure on the triangles, we said the perimeter followed the same rule as all the sides do with scale factor. So if I add up all the sides of my original square, 2, 2, 2, and 2, I have 4 of the same sides that are length 2. So I'm going to have a perimeter of 8. The perimeter of my copy, 10, 10, 10, and 10, will be 40. And can I multiply the perimeter of the original times my scale factor? Yes, I can. It's continuing that same pattern. So let's see what happens to the area. To find the area of the square, I'm going to multiply the 2 sides, or 2 times 2. So the area here is 4 square units on the original. 10 times 10 on the copy is going to give me 100 on the scaled copy. So what number can I multiply 4 by to get 100? I would have to multiply by 25. Okay, so answering those two questions below, this second activity, what happens to the perimeter? It's still getting 5 times greater when it's a scaled copy, just like the sides of the figure do because of our scale factor. But what happened to the area? It got 25 times bigger. So now let's look for a comparison here. If we go back, we look at the comparison between the scale factor and what's happening to the area. All right, what are some ways that we could get 4? We could add 2 and 2, but with scale factor, we don't like talking about adding and subtracting because that distorts our figure. We said we should always be using multiplication. So I could multiply, let me do this in a different color, 2 times 2 to get 4, and that was the amount of change. 4 times greater is the area of the scaled copy. If I look here, I can do the same thing. I can take my scale factor of 5 times 5 to get 25, which represents the change in the area. And that is the rule for today. All right, the rule for today is you can take the scale factor times itself, the scale factor times the scale factor, to find how the area changes in a figure. So I am going to write that down, and I would like you to add this to your Know It notebooks. We're going to put the area of a scaled copy is increased, or let's see here, let's say is changed by the scale factor times itself, the scale factor. Okay, now another way to say that would be the scale factor squared, or using that exponent of 2 to represent it. Okay, so you could say the scale factor squared, because that means the same thing as multiplying it by itself. Okay, give question 3 and 4 a try, and now we're going to move on to the last activity, which is right before the lesson summary. So you can see that we have a rectangle here. The sides of the rectangle are not labeled. We're only given 20 square inches. And because of the label, square inches, I know that this is the area. The area of the figure is 20 square inches. Now, the question says, Lynn has a drawing with an area of 20 square inches. If she increases all the sides by a scale factor of 4, what will the new area be? So a scale factor of 4. Now it says if she increases all the sides, but we don't know the lengths of the sides. So going off of what we just learned, I should be able to take the scale factor times itself to get the change that will happen to the area. That is what should happen here. So that would mean that if we have an area of 20 square inches, now that area is going to become 16 times greater because of taking the scale factor times itself. Now, 20 times 16 is what we need to figure out to find this new area. 10 times 16 is 160. 20 times 16 should double that amount because I'm taking twice the number of groups of 16. So instead of having 160, I have twice that. So 320 square inches should be the size of my scaled copy. And I think because we're new to this, this would be a great thing to check. So what I want to do is come up with 2 side lengths for this rectangle that will give me an area of 20 square inches, since we weren't given a measurement for the side lengths. Let's say 4 and 5, because 4 times 5 will give me 20 square inches for an area. So this could be the side lengths of that rectangle. Now, if the scale factor is 4, I'm going to increase each of these corresponding sides by a scale factor of 4. So 4 on the original is now going to be 16 on the scaled copy, and 5 on the original is now going to be 20. Well, guess what? 20 times 16 is 320 square inches. So we found that. So let's make sure we answer this question correctly. What will the new area be? 16 isn't the answer. That's how many times the area increased. The answer is actually going to be 320 square inches. All right, the second part says, Noah enlarged a photo by a scale factor of 6. The area of the enlarged photo is how many times as large as the area of the original. All right, so we have a photo that we'll call the original, and then we have an enlarged copy of that photo that use a scale factor of 6. So you might jump to saying, oh, well, the area is 6 times greater. But remember, that's not true. For area, which doesn't fit that scale factor pattern, it's actually scale factor times the scale factor. So 6 times 6 is how the area of these two figures changes. So 36 times greater. Now, if you think about it, area is calculating a two-dimensional space, a flat surface. So if we are saying the scale factor is making this photo 6 times larger this way and 6 times larger this way in a second dimension, that is why we're increasing 36 times more than what the area of the original is. We're getting 6 times greater this way and this way in expanding that. So I hope this was helpful. Please read over the summary in your packet for lesson 6 just to review what we just talked about, and make sure you answered question 3 and 4 in the first part of the packet. Then don't forget about your practice problems on Canvas. I'll be on Zoom to help you out if you have any questions, and I hope you have a great day.